All right. Hello, everybody. Welcome back to Comp 2450. I hope you're all doing okay today. Today, what I want to do is spend just a little bit more time talking about testing. This is going to wrap up all the testing stuff that I want us to be able to think about in this course. When we focused on testing initially, what we were focusing on was effectively testing the validation of objects, but that kind of left a big spot that was open in terms of testing our logic layer methods. And so I want to spend a little bit of time talking about that. The overall idea of testing these things is the same. They're still just methods. We're still just providing inputs. It's that the inputs are going to be possibly a little bit more complex in the sense that they are domain model objects and not just strings or integers anymore. So I want to spend a little bit of time thinking about that. I want to talk a little bit about an idea that directly comes from what we're doing with dependency injection, but I'm going to say it now. I'm not expecting you to do this for your project. I just think it's cool, and I want to show it to you because I think it's cool to be able to do something like this, but I'm not expecting you to need to do anything like this for your project. And then after that, with the rest of the time in class, what I want to do is kind of take a high-level overview of like the things that we've done in the course so far, getting us to this point of we started with building these objects, and now we have this kind of complex 4 or 3 layer system where they're all interacting with each other with these domain model objects. And so I want to take a kind of a high level look at everything that we've got so far. Before we get to any of that, though, I want to tell you what's going to happen next week because I want to give you lots of notice that something different is happening next week. There will be a news item that's posted on the course webpage after class today to also tell you about this. And I will also remind you on Friday's class, just in case there's different people here and the people that aren't here today haven't watched the live stream and so on and so forth. Next week, the topic overall is I want us to be able to start thinking about software in a broader context. So I know that I've been trying to push this idea to you of like, we're building this software for people, but in reality, you're still just building it for yourselves. You're the only people that are actually typing stuff in. Maybe you've shown your parents. Has anybody shown their parents their code? Awesome. Okay, awesome. I'm really happy to hear that. Thank you for sharing that. Yes. But I want other people to tell you about this. For, I guess, complete transparency, I did work, and I'm going to put this in major air quotes here, in industry for a while before I started working here as an instructor. When I say in industry, I was working effectively in an academic research lab, just not on campus at the university. I worked at the National Microbiology Laboratory for about 10 years, and I was doing a lot of Java web development there, and then also a lot of like software development for the purpose of microbiologists using software. And let me tell you, microbiologists do not know how to use software. They're really bad at it. They use databases a lot. They have a lot of databases that are filled with genetic sequence data. But they're plain text files. They're multi-gigabyte plain text files. And that's the kind of thing that I was working with when I was working there. So I did work in industry for a while. I'm a little bit removed from that. But next week, we're going to have a couple of guests. And I actually realized I inverted this, so the guest order here is different. But on Monday, we're going to have Mr. Seth Roof. He is a senior software developer at a company called Varian. And he's going to tell us a little bit about the kinds of things that he does on a day-to-day basis in terms of software development, including things like talking about the relationship that he actually has with clients for the company that they have. So what kinds of things they do for planning, how much clients are involved in the kind of day-to-day stuff. The other person I've invited to come talk to us is Dr. Shaiful Chowdhury. Shaiful is a department member. His research focus is on software engineering. He focuses primarily on things like software quality, software testing, and in the past, he's done things related to energy use with software. So he was researching things like how much of a battery on an Android phone does this snippet of code actually use when it's put into production on millions of devices. That's the kind of research that he was doing. In both of these cases, we will ideally have lots of time for you to ask questions. So please feel free to ask questions of these two people when they come. I'm also just going to have a bunch of questions prepared because I don't want to have awkward 15 minutes of silence while they stand up here and say nothing and you all say nothing back at them. But I strongly recommend that you take the time to ask questions if you've got questions for them. I'm telling you this in advance because I'm not recording these lectures and I'm not live streaming these lectures. I think it's important for me to live stream and record class material and course material for you, but I can't obligate somebody else coming into the classroom to do the same thing, especially for Seth, who might be talking about stuff related to what Varian does that can't necessarily be shared publicly forever on YouTube. And same thing with Scheifel. He may have research that he's just not able to talk about right now or willing to talk about permanently on the record on YouTube right now. So we're not going to be having any recording or live streaming for those two lectures. We'll still have a quiz that week. The quiz will be effectively asking you to tell me about what you saw at those lectures. So what those two guests were talking about. Again, there's not going to be live streaming or recording for those lectures next week. Okay, so yeah, like I said, this will show up on the course webpage, and I will remind you again on Friday's class that this is happening, just to give you lots and lots of notice that it's going to be happening. So let's talk a little bit about testing our logic layer methods. Testing logic layer methods is something that we've kind of omitted. We spent a lot of time thinking about testing input validation. Again, for clarity, from the perspective of we're testing these builder objects that we created and making sure that they are throwing the right kinds of exceptions, or eventually we're able to make observations about the state of an object that gets constructed by these builders by asking questions with their accessors. But that kind of leaves these logic layer methods as not described in class. And so I want to spend some time describing in class some of the ideas related to testing logic layer methods. Logic layer tests, yes. The overall idea of testing your logic layer is going to be something you should do as part of your project. Yes, that will be part of the coverage that we're doing. There's a very specific thing closer to the end that I'm going to talk about that I'm not expecting you to do related to this. You can, and I think it's awesome if you do it, but it's not something I would expect you to necessarily do. So logic layer tests, these are going to require some more complex state setup. Basically, we're making domain model objects and we're passing those domain model objects to these logic layer methods. So there has to be some kind of more complex state setup to get to it. But the state setup here really is just hard-code it. You got builders, just call the builders with hard-coded values in the tests that you're setting up so that you can establish conditions that are going to cause the behavior that you're expecting to observe. The tests that you're writing should still be independent of each other. And so what I mean by that is it shouldn't really matter what order they're run in, but it should also not kind of say that the output from one test causes another test to pass or fail. We shouldn't have any dependencies between the tests that we're writing. They should still be independent of one another. And the specific part that I'm thinking of that I'm not necessarily expecting you to do is related to persistence and the point above this one. Persistence might mess things up about this idea of having independent tests. So there's two solutions that we can do. There's one that I think is reasonable for you to just do right now. And the first thing that I think is reasonable for you to do right now in terms of dependency injection and logic tests and persistence is just inject temporary files into the persistence layers that you're using in these test methods. So the JDK has this method in the files library that's called create temp file. It makes an empty file, and then you can pass that empty file to your persistence layer that you're injecting into your logic layer as you're doing the logic layer test. That way you're going to guarantee that every time you run this test, the file will be empty every single time you start. When we're doing this with the UI layer and we're actually running this code, we want to hard code that file name because we want to save the state. We want to persist the state after our application stops running. And we want to get back that state once our application starts up again. But in the context of a test, I really want a clean slate every single time I start every single test. And so rather than using these hard-coded files, let's just make these temp files for every test. And then we'll use that temp file injected into our persistence layer dependencies. The other option, and this is the thing specifically, so I'm calling this out very clearly, option number 2 here is not what I'm expecting you to do. The other option is to inject mock persistence layers into your logic layer. A mock is a type of class or implementation where what it does is it effectively pretends to be an implementation of this other thing, but it's effectively non-functional. It doesn't do anything. It doesn't null pointer exception. It doesn't throw exceptions. It just does effectively nothing. But it allows you to call the methods on it. Often, this is going to be in the form of anonymous inner classes. This is, in terms of like the leap from 1020 to where we are right now, this might be the most complicated thing we've done in this course in terms of like programming language structures in Java. Have any of you seen the words anonymous inner class before? Oh, many of you. Where? Oh my God, that is wonderfully like complimentary here. Awesome. Okay. Well, this is the most complex Java stuff that we're going to be doing in this course is anonymous inner classes. I'm still not expecting you to do anonymous inner classes and mocks for phase 3. Whether you're doing it in 2400 or not, that's not something I'm expecting you to do, but I want to show it to you because I think it's neat. I think it's really cool to be able to do this with the idea of dependency injection that we've got here. I want to take a look at a couple of different scenarios. The first scenario that I want to take a look at with regard to the test, that we've got right now, is that when we have insufficient PP for a move, when we do the attack method in the logic layer method should throw an exception. The input here is I've got a Pokemon that has 1 PP left. I make a move. The next time I make a move, I expect that there's going to be an exception raised. That's the behavior that I want to make observations about in this case. And the other one that I want to make observations about is when a Pokemon faints, as a result of doing the attack, the state of the battle should become over. That's not exceptional behavior. This is just the thing that I would expect to happen. Given input of or the state of a Pokemon has 1 HP left, it gets attacked, that HP is gone, the battle should be over now. And I should be able to make that observation by asking questions about the state of the logic layer class that I've got. So I'm going to pop over to my 2450 Amon example here. At the back, can you quickly confirm that that's big enough for you to see, or should I make it bigger? Make it a little bigger? Okay, thank you. Oh, come on. There we go. Is that big enough? Awesome. Thank you so much. The first thing that I want to test here is I want to be able to test that I have the correct exception being raised in the circumstances where there's a Pokemon that has no PP left. So this is me effectively going through and evaluating the behavior for some kind of logic layer methods in the non-happy path approach. I want to make sure that this thing is going to happen the way that I'm expecting it to. So the first thing that I really want to do here is I am going to have to start setting up the state for this thing. Setting up the state for this I want to set up a state where I have a Pokemon that just has 1 for max HP. And so I will be able to attack once, but the second time I attack, I shouldn't be able to do it anymore. A passing scenario here is effectively that an exception is raised as a result of trying to call that attack method again. And so I'm going to have to start building a Pokemon to be able to do this. I'm going to have to say Pokemon P, and to do this, I'm going to have to use the builder class that I've got set up for working with Pokemon. I've hidden the constructor for this class, so I must use the builder class that I've set up. So I'm going to say new Pokemon builder. And what I'm going to start passing to this is, I need to hard code stuff so that I can get a valid instance of Pokemon. So I'm going to say things like the nickname is, gosh, I don't know. Who's got a good nickname for this Pokemon? Disappointment. Oh. I'll even put a little sad face there. Disappointment. Yeah, okay. I think that's actually technically longer than we would be allowed to enter in a Game Boy Pokemon game, but sure, we'll go with it for today. In later ones, it works. Okay, you named your trainer that? Okay. Okay. We're going to set our max PP. We're going to set our max HP for this to be something bigger than causing the Pokemon to faint. I don't really want my Pokemon to faint in this case. So I'm going to set this arbitrarily to be 10. I don't want this Pokemon to faint after doing any attacks against it. The other methods I'm going to have to call are type. What kind of type is a disappointment? Phase 2? We've got grass, fire, electric, normal, or water. Normal, okay. A normal disappointment, okay? And we are going to have to give it a move. Pokemon must have move. Okay, so I'm going to actually have to also then go through the process of building a move here. So I'm going to say that I'm going to have an attack. I'm going to call this tackle. The attack in this branch that I've got here, I've created these attack builders. Sorry, this is tackle builder. That's what I'm trying to build here. And what I want to be able to say about tackle builder is that its max HP is going to be 1. I want it to have exactly 1 when it starts up. I'm also then going to say that the current HP for this is 1. I could hard code this as 0 if I really wanted to force this to happen, but I'm just going to say that it's 1 for now in both cases. So I've got with move here, and now I'm going to be able to say tackle. And then finally, I'm going to say build here. So I've constructed my instance of this Pokemon with the max HP of 10 and with a single move that has a PP of 1. There's a bunch of exceptions that are being thrown here. And that makes sense because these are the exceptions that we're trying to protect against with input validation. In this case, I'm confident that all the things that I've hard-coded in here are valid. And so I'm going to effectively wrap this entire thing with a big try-catch block. And I'm going to catch exception here. If I catch any exception from what I've got right now, then what I want to be able to say is this is a failure. There is a specific exception that I'm expecting to get as a result of something that I'm doing here, but any exceptions that are thrown from these methods, that's something that I don't really want to concern myself with for this specific test. And I think I missed build here. Yeah. I'm also going to do e.print stack trace here. My parents are not running these tests. I want to know why I failed. I want to know why I failed. I want to know what caused this thing to fail. So I'm going to print out a stack trace here. So I've got the setup. Everything here is hard-coded. The very last thing I need to do is I need to set up a trainer here. So I'm just going to set up my trainer. So disappointment is the name of our Pokemon. What's the name of our trainer? Ash. Okay, very traditional. Thank you. The name is Ash. Balance, let's say they've got 100. With Pokemon, we're going to give them this Pokemon P, and we're going to build it. Okay. So all of our builder methods are throwing these exceptions. We don't care. If any of those throw an exception, then we want to cause this test to fail. We want to say that this test has effectively failed. Now what we want to do is we want to set up our logic layer. So the way that we're going to set up our logic layer is we're going to make an instance of the logic layer class here. The logic layer that we're testing here is battle. So I'm going to say battle B is equal to new battle. This class takes as input 2 trainers, but I actually don't have any logic that says it can't be the same trainer. And so I'm just going to put the same trainer in twice here. That might be an invalid state. We could talk about that later if we wanted to. We could put that in our preconditions in class invariant, but I'm going to take advantage of the fact that I've overlooked this for now. So I'm going to say that I'm going to have a battle between trainer and trainer. And for right now, the final thing that we have as a dependency in this class is the persistence layer for our battle. So for us to be able to save the state of our Pokemon and trainer. I'll come to you in just a second. For right now, I'm going to pass null. But I know that that's going to fail. That's going to fail with a precondition failure. This is not going to work, but I just want to get to the next part before we come back to this part of it. Yeah?
In your first exception that shouldn't the first example happen be like the no exception?
The exception that we're catching here, that's a good question. For now, the exception that we're catching here is meant to handle exceptions that get thrown from anywhere here. But for the case of testing no PP, I don't actually care about any of these exceptions. And again, I'm confident that I've hard-coded in what all of those things should be. So I do want to have a catch-all that says any other kind of exception that gets raised, I want to fail this test. I'm going to add, I will add this. I will actually add the there's no PP left exception that gets raised by this thing. But for the case of I've got all these exceptions being thrown by these builders, I just want to handle them basically. Yeah. Yeah. So that's a good point. We are running all of this code, but we're not actually testing it. I would say that we're not testing any of the builder code here. It's coincidentally evaluated, yes, but it's part of the setup to get us to the thing that we actually want to make observations about here. We're going to have, and we do have, different classes that are evaluating the behavior of these builders. So separately, they're going to be evaluated using hard-coded inputs, and we have the correct like try and catch setup for each of those different methods that we've got. Here, again, this is just a coincidence that we're also running those things again. We could say that we're covering this twice, I guess, in that sense. But for us, this is just set up for the test that we're doing here. Yeah. Yeah. Yes. In this case, it's not invalid for our Pokemon to have no PP, but it is invalid for our trainer or person running the software to ask to use a move that has no PP. That's the state that we're evaluating right now. So it's not so much testing invalid state here, it's testing an illegal operation, basically. You're not allowed to use this move that has no PP anymore. You could, yes, but if you call that, if you give the responsibility of calling that method to the UI layer before it calls the do attack method, then the person writing the UI layer could forget or just intentionally omit that. And so I want to force that person to have to handle this exceptional state. And I want to verify that this exceptional state happens when we have the right conditions for it. Yeah.
Would it be make a method just for constructing the object? I understand that we're constructing the Pokemon differently, but say we did a general one or something.
Sure. It would be reasonable to have a convenience method in this test to basically go through and set up all this stuff for you that you just call in advance of this thing. The thing I want to make sure that you're considering with this is that I'm still making new instances of these classes for every method that I'm going to write. Even if I have this convenience method, I don't want to have a file level or class level variable of the type Pokemon that I'm just reusing over and over again. I want to make sure I've got a clean slate for every single test method that I'm evaluating, so that I don't have situations where one test coincidentally running before the other one causes the next one to succeed or fail based on the results of that one. That would make it, the reason I'm saying that is it would make it really hard to find out what the actual failure is there. Yeah. Okay, so for now, I'm just going to put null because I just want to ignore the fact that we have this dependency. And the situation that I want to be able to run here is I want to be able to say battle b.attack, do attack. And the move that I want to select is move 0. So when we create an instance of this battle with these trainers, the first trainer that we have as the argument here is the one that goes first. This first trainer has only one Pokemon. This is the one that's currently selected that only has one attack, so it's attack number 0. So I'm going to call this logic layer method with selected move 0. And here is where I'm going to put the try-catch block. So I've got a try-catch. The external try-catch is just the catch-all for all other kinds of exceptions. This internal one is effectively going to say catch, no PP exception, no PP left exception E. If I catch this, then pass. I got the no PP left exception when there was no PP left. That's what I was hoping to have happen here, is that this failed successfully. If I call do attack and no exception is raised, then this is fail. I was able to use a move that has no PP left. And because I said this, the current PP was 1, I'm going to need to do this twice, just for completeness here. So b.doAttack. So now I've used that same move twice. The first one causes it to go to 0. The second one that I try to use it, it's at 0. I'm not allowed to use this move anymore. So the setup for logic layer method testing here is a little bit more complex. I don't just pass in a single string, but I'm still hard coding everything. And I'm hard coding everything to get myself into these situations where I'm going to be able to make observations about the state of the software, the state of that class that I want to be able to make. So in this case, there's a lot of setup here in terms of the structure that I'm passing to this. And the observation that I ultimately want to make is that I wasn't able to use this attack twice that only has one PP as part of it. It's generally okay with everybody? Okay. If I run this, it's going to fail. It's going to fail hard, and it's going to fail with null pointer exception because I passed null to the persistence layer here. Got preconditions in this battle class that forbid me from passing null to this constructor. I've also got method calls that I'm making on this object that are going to fail if I try to call methods on the null object. And so I've got to do something about this persistence layer. The first option that we've got is I can use temporary files to inject into the dependency that I've got here. I'm going to write this both of these options into this method for now. The version of this that's going to be posted up to the course webpage will have 2 different methods that do the different things, but just for time purposes, I'm going to put them both in this one. The first option that we've got is we want to be able to pass a temporary file. So option 1 for dependency injection, persistence layer. I want to be able to pass in a temporary file to this thing. To pass in a temporary file, I can just use create temporary file method on the files class to be able to do something like that. So what I'm going to say here is path temp trainer JSON is equal to files.create temporary file or create temp file. This takes 2 arguments that we must apply, a prefix and a suffix. These are kind of just like the prefix is going to be what's put at the beginning of the file name. The suffix is what's going to be put at the end of the file name. The file name itself is going to be filled with kind of random looking characters because it's a temporary file. This is something that didn't exist before. So what I'm going to say here is something like this, trainers and JSON as the suffix. And that's it. I've made a temporary file. This file is empty. It has nothing in it. So when I start doing tests with this thing, there's going to be nothing to load. There will be nothing in this file. It will be completely empty. For every test that I write that has these dependency requirements where I have this file for persistence, I want to make this empty file for every method so that I don't have to worry about the results of one test affecting another. So I've got this temp trainers JSON. Then what I'm going to be able to say is persistence layer for trainer persistence. JSON trainer persistence JSON. And what I want to pass to that is temp trainer JSON. And then once I've got this pre-constructed version of my dependency, I can pass that as an argument to the constructor here. That's option one. The other option that we can have here is we can say that use an anonymous, I can't say the word, use an anonymous inner class. Use an anonymous inner class to represent this dependency as opposed to using the actual implementation of this thing. What that looks like here is B is equal to new battle, trainer, new trainer persistence. So this is the name of the interface. And when I do this anonymous inner class, as you saw in Comp 2400, you get the methods. You have to fill in the methods here. For us, in this very specific case, where I'm calling this do attack methods, and the points of persistence I have are after the battle is over, I know that these methods aren't even going to be called. I know that they're not going to be called. I can look at the code in the battle, the do attack method. I can see that they're never going to be called. So I'm just going to leave them as returning null. It doesn't actually matter because these methods will never actually be called by anything in this specific case. In other cases, so you want to actually measure that the battle has completed, using an anonymous inner class here might be you take that input and you put it in a map, but you don't actually write the file out. You just save it in the map and then you're done. You don't do anything with it after that. For you, for this course, for testing your logic layer, I would expect you to do something like this. So passing in these temporary files so that you have a new empty file every time you start one of these tests, as opposed to doing anonymous inner classes. I welcome you to use anonymous inner classes if you want, but it's not a necessary thing. Yeah.
Just looking at it, I'm assuming if we do a bunch of tests, we'd have to do that same anonymous inner class multiple times. Would that make sense to instead, like, just make a private inner class?
That's another option. Yeah, that's totally another option. Instead of having an anonymous inner class here, you could also have a private inner class here that just does the map thing. You just make new instances of that every time, as opposed to having 20 lines of code every single time you want to make this thing. Yeah. Option two, no, I think it's just neat. Yeah. All right, okay. So I've got this up. I've got something that looks very much like this up on the course webpage, linked to on the course webpage. The branch that I'm working with right now is called Logic Test with Persistence. I will merge this into the main branch after today's class. So what you'll see in the main branch is something that looks a lot like what we've got here. Okay, so I would like to take some time in the last 15 minutes of class here to take a look at some of the topics that we've looked at throughout the course, to try and tie things together in a bit of a more holistic picture than the bite-sized things that we've seen every week so far throughout the course. So way back at the beginning, there was a black cat and his name was Walter, and I adopted him from the Humane Society about 11 years ago, so he's getting to be an old man cat. When we adopted him from the Humane Society, he would not shut up until we picked him up. Like, it was just constantly meowing. And of course, it's a kitten, and we pick him up, and he's adorable, and he stops meowing when we pick him up. It doesn't tell us, of course, that when we put him down at home, he's just going to wander around meowing all the time. He is a very loud cat, and I love him so much, but he's very, very loud. And also, he bites me sometimes. In the beginning of this course, we started to talk about domain modeling. And this was kind of our first foray into the idea of design. So rather than just diving headfirst into coding, we want to spend some time building up some mental structure or some diagram or something that represents the core ideas of the system, the high-level ideas of the system and concepts that we're going to be implementing ultimately in the software that we're building up. This is usually something that happens high-level designing before we start coding. This is almost always in industry and in practice something that happens with your clients, with regular non-technical folk that don't have any idea what you are doing. They see you typing away at this computer and you're just typing in magic words. They don't know what's going on. So they're going to be the people that are experts in the domain that you're trying to build software for. And so they're going to be involved in coming up with some of this design stuff that you're building up here. The domain modeling goals that we have are really that you have these experts that are non-technical. You have people who are very good at their job and people who are very good at the domain that you're trying to build up software for, but they're non-technical. You are a technical person and you're not an expert in that domain. And part of the exercise here is that you're trying to get a shared language between the two of you. They're going to tell you some of the words that they use to describe the problems that they are trying to solve. You're going to be able to encode those words in the software that you're building. And when you talk to them about the stuff that you're doing, you'll be able to use those words as opposed to talking about public and private classes and integers and floating point numbers. They don't care about that stuff. They care about money and the measurement that you take for this thing as opposed to the values and types that we're using internally here. This is also going to be giving you some of the initial structure, and this is later now in the course, but some of the shared language that you're going to be using and the communication tools that you're going to be using in the code that you're writing. So as you're building up these layers of responsibility for the software that we're building, we're using these domain model objects that we're constructing with the help from our client, from our non-technical person, to be able to communicate throughout these different layers of responsibility. I make instances of these domain model objects and I pass them to other layers of responsibility to do something with here. The key ideas that I want you to keep in mind with this domain modeling stuff are the design philosophies that we talked about very early in the course. You ain't gonna need it, and keep it sweet and simple. When we're working with real people, when we're working with real clients, they are often terrible at knowing what they want, and they are often terrible at communicating what they actually want to you, even if they have a solid idea of what they want. Building more before you're able to give it to them for feedback means that you have more stuff that you need to change. Building more than they ask for means that you're going to have to remove stuff possibly. Building more means there's more places bugs can be than otherwise if you didn't build more. Keeping in mind these design philosophies, keeping in mind the design principle, very specifically what we were focusing on at the beginning was the single responsibility principle, making sure that each domain model object does just management of the properties that it actually has responsibility for. The other thing that we did as part of this was modeling the relationship between instances. And the idea here was that we had these different kinds of relationships between instances of classes in the form of composition and aggregation. And this was modeling effectively ownership between different instances that we have here. And then later again, just like this is informing how we're doing our layers of responsibility, this is going to inform persistence strategies. One small idea I want to add to this is prefer composition over inheritance. I've never actually used these words in this class. John may have used these words in his class. A lot, okay. Well, I'd like to add that to our course, and I'd like to echo what John is saying. Prefer composition over inheritance. Inheritance is a fine tool. It does what it needs to do, but in a lot of cases it gets overused, and specializing things makes it becomes difficult when you're using inheritance. Preferring composition over inheritance, so making objects that are composed of other objects, makes it a lot more easy to have some flexibility with the structure of that. After designing our domain model, we moved on to this idea of design by contract. And part of what we were doing initially with, let's use this non-technical language and the class diagrams that we're building up, was really to begin thinking about this stuff. When we're designing our domain model and we're using these non-technical terms to describe some of these ideas, what we were ultimately doing was, these are assumptions that we're going to have about the values that we're putting in these objects in the end. There is no positive integer type in Java, but by writing positive integer here, I'm starting to put down some of the assumptions that I have about the actual values. One assumption that I have about this picture is that there is another half of a cat in that box and not something else. Walter loves Christmas time. Walter adores Christmas time because there's always so many boxes. Christmas is often more fun for cats, I think, than it is for people. But he does eat a lot of ribbons, and that does make him sick, and I don't like it when he does that. And so we have to be very careful about leaving ribbons laying around the house. Design by contract was about making sure that we're taking these assumptions that we've made, so this value should only ever be positive, and beginning to actually encode those assumptions into our code as assertions. The focus here is about preventing programming errors from happening, and it's not about input validation. If we had a Venn diagram of these two ideas, they would overlap a little bit. There are some things that we're doing in both places, but the goal with design by contract is to prevent programming errors as opposed to input validation. Coincidentally, they both might happen, but the goal is about preventing programming errors here. We had three major ideas with this. First was this idea of a class invariant, and the class invariant is effectively describing all the valid values that an instance of an object can have at runtime. So what values should this thing hold at runtime? Often this is not null, but in the case of things like integers, in the case of things like dates, it might be positive. It might be that it can't be for today, for example, but often with complex objects, this is not equal to null. We want to stop null pointer exceptions from happening before we get further into our code. Preconditions, the second big idea here was what effectively must be true about the state of where we are right now before we can continue. This is often calling this class invariant within the context of domain model objects, but as we get into logic layer classes, this is now things like checking that the values that are being passed to us are valid in the context of what we consider them to be valid. And then post conditions. So what are we going to guarantee to the person that's calling this code before we actually return control to them? And again, this is often calling the class invariant. I've made changes to myself. I want to make sure that I'm still valid before I give control back to you and you proceed to passing me around to other places. Then we kind of return to this idea of designing things. And Walter is quite a beautiful cat. I really do like him. He's very majestic looking, especially when he's sitting in the sunshine like this. He looks great. He's very handsome there. This is another design activity. And the design activities that we were doing here was our domain modeling is what's the language that we're using to communicate with the people that we're building the software for. Designing flows of interaction here is how are people actually going to use this software to accomplish tasks? They're going to use these domain model objects as part of that language, but we really want to know how they're going to accomplish that task in an abstract way. The idea here is that I want to focus on the kinds of things they're going to give me as input, and I want to focus on the kinds of things that my system is going to do as a result of that input. So I'm going to have these input subtasks. These are the things where we're asking for inputs. These are prompts in the text-based system that we've got, but this could realistically be a GUI that has text fields in it and a button that I'm pressing. The processing subtasks here are when I press that button or when I press enter after having provided all of the inputs that I need to provide, what is my system going to do as a result of that? How is it going to transform its own state? How is it going to transform the domain model objects that we're passing to it? And what side effects should come as a result of that in the end? The goals here are, again, I want to be able to share these ideas with non-technical people. I want to be able to talk to the experts in this domain about how they're going to use this software without writing the software and without actually having code that I've written to show them on the screen yet. I want to be able to communicate with these non-technical folk how they're going to actually flow through this software. This does give us some idea of how we're going to implement all this stuff in the form of giving us some sense of this is a processing subtask. It probably belongs in a layer that should just do processing stuff. This subtask is getting inputs. It should probably belong in some part of the code that's responsible for getting inputs. That gives us a segue to thinking about the layers of responsibility. And my cat has not been baked into this Vina Tarta, but I do love Vina Tarta. This is taking those flows of interaction and thinking about the kinds of responsibilities that we've got here and starting to implement them into actual software here. The idea here again was we're focusing on the single responsibility principle, but we're no longer focusing it on the micro class level. Now we're focusing on it from the perspective of all of these classes should be for input and output. All of these classes should be for doing logic layer stuff. And then eventually all of these classes should be responsible for just doing persistence. They're all going to talk to each other using domain model object instances. And the structure that we had for that was something that looked a little bit like this. We've got this person using our keyboard. They're typing stuff into the user interface layer. And then the user interface layer is asking this logic layer to do stuff. We're returning stuff all the way back to the beginning again here. We're separating these responsibilities out. We eventually then added this idea of input validation. So making sure that we're able to communicate errors of input to non-technical people. Where design by contract was protecting against programming errors, and that's Walter in a costume that I designed for my son a long time ago that he never wore because it was extremely awkward to get upstairs, and getting upstairs is impossible when you're trying to go around trick-or-treating and getting candy from people. Our approach with this input validation stuff was that we're going to delegate the construction of these domain model objects to these things that we're calling builders, especially when it's responsible for validating input from our person, our non-technical person. And the goal here was effectively, I want to forbid the construction of invalid instances from ever being made. And so I'm going to make this constructor private and force you to use this builder class. But I've got this guarantee now. No object that's constructed with a builder can be invalid. It must be valid for me to be able to have an instance of this thing in the first place. This is also later then going to be used when we're thinking about loading stuff from persistence files so that we can make sure that the files that we've got here are also going to be valid. We also talked a brief moment about idiomatic errors. So in Java and Python, idiomatically, what we do is throw exceptions when there are exceptions to be thrown. Where in languages like Go and C, we're doing return-based approaches. For us, what we were doing was spending a lot of time writing custom exceptions. And the goal here is that I want to be able to communicate these errors between layers and boundaries in such a way that the user interface layer knows what to print out based on the kinds of exceptions that are being raised by the different layers that we've got here. Eventually, we got to testing. And I love it when Walter does this. The idea here was that design by contract is preventing our programming errors from happening. Our input validation is preventing user input from causing errors. We want to be able to make observations about the behavior of the code that we've got. So I want to be able to write code that's running this code and make these observations about it. We got two different kinds of test data, general case and edge case test data. So general case is valid, the happy path, and the edge cases are going to be things like we're trying to go through and look for stuff that may raise exceptions as inputs. We built up this test harness that runs the test cases that we've got and collects all this information about test cases. And finally, we got to persistence here. The idea here was that he also drools a lot, especially as he's becoming an older man cat. He drools a lot. Here, we're trying to save the state of our objects to permanent storage, and we're starting to use a new kind of approach to this, which is dependency injection. This is the D in solid. We want to satisfy this dependency inversion principle, and so we're going to use this idea of dependency injection to accomplish that. The structure that we've got here is that we're using those relationships types to inform the strategies for persistence. And this is the structure that we have at the end of all of this. All right, so thank you for 1 extra minute of your time here. At this point, you should be able to implement a test harness that tests the logic layer. I hope you all have a great day, and I'll see you all on Friday. Bye, everyone.